Good morning. Good morning, everyone. Thank you for coming to the session. So how many of you have actually used Azure SQL Database in a production or a development environment? Like, quick show of hands. OK, good. That's a good number. So my name is Amit Banerjee. I work as a group program manager at Microsoft. I'm responsible for the on-premises database engine, which you know as SQL Server. And I'm also responsible for the Azure SQL Database Edge product. Today, what we're going to do is we're going to talk about Azure SQL Database Edge. While there's a name Azure in front of it, this thing runs outside of Azure. It runs in devices as small as this. What you actually see over here is a Raspberry Pi that's actually running a Azure SQL Database Edge container. So we're going to understand how this actually works, where this is actually useful, and why would you actually put a SQL engine on a device like this? So if we look at our current scenario today, like the world is kind of evolving where you have three different targets. You have the cloud. There's a lot of cloud computing. There are major cloud providers that provide services in the cloud. There is a set of services. There are a set of databases that actually run in your data centers today, where you run databases like SQL Server, Oracle, Postgres, MySQL. And then there's what we call the edge. So for example, when you actually walk into a store and when you're checking out of a shop or a grocery store, there's a point of sale machine that is actually making a call somewhere to a central server to get that information, or whether the card details are valid. All of that requires you to go over a network and make a connection. That connection could be to a server room sitting in the back of the store, or could be to the cloud, or could be to another data center that's sitting somewhere else. But what if the data that is being generated is generated at a very, very fast pace, and you need to make decisions right then? So a good example is, how many of you have like blind spot monitoring in your car? OK, a few of you. So in the blind spot monitoring, when you're actually trying to change lanes, if that light doesn't come on at that time, that could be a fatal mistake. Imagine that thing trying to phone home somewhere to figure out if there is a car. That probably would not be a good scenario. Or an emergency braking system, or even your airbags. Like every car is an airbag. Imagine your system in the car phoning home to figure out if it needs to deploy the airbag. So those are mission-critical systems which need to make decisions on the spot, and you try and eliminate as many variables as possible. Like when I set up demos, I try and self-contain all of them in a laptop. If I need to go over the wire, I try to have backups. But what I'm trying to do is I'm trying to eliminate the need to fall back to something so that everything is self-contained. So wherever real-time decisions need to be made, you actually have to get to a place where you're able to make those decisions without having to depend on an external factor, especially when the time to react is a few seconds. So in terms of numbers, this is what we see as projections from various analysts and various information that's available today. By 2020, there are going to be 20 billion connected devices. Each of the phones that you're using to actually take pictures right now is actually a connected device. Each of the wearables that you're wearing, those are also connected devices. And the numbers of those are increasing every year. They're not going down. Even the amount of data that these devices generate is humongous. Like having 64 gigabytes on a phone as storage, you couldn't think of that 10 years ago. Now imagine if all of that data had to be backed up every day. That's going to be a huge LTE bill that you'd get. And probably even your network. If all of you in this room started to back up your phones to a cloud storage right now, the Wi-Fi would actually go down. So how do you actually minimize the amount of data that's actually sent back? A lot of that data might not even be useful. Like, for example, the GPS location that your phone is emitting. You don't need to store that every second in a central database server. So how do you process that data locally, and how do you actually take real-time decisions? So this is how we think of the scenario today. So one is our cloud. Microsoft has Azure as its cloud. We have the SQL Server engine that you have there is Azure SQL Database. That's the same SQL Server engine. It powers our PaaS service. If you want to run SQL Server in a virtual machine, you run SQL Server on an Azure virtual machine, and you can back up and restore your databases to managed instance, or you can back up and restore your databases to a VM, and you have SQL Server running in the cloud. Now, if you want to run it in your data center, you have the option of installing SQL Server on Windows or Linux, and you can choose to run SQL Server there. Now, what if you had to walk around with SQL Server? Like, what if you needed the same kind of data processing capabilities that SQL Server offers, but you had to do that on the move? Imagine carrying a server on your backpack. Probably not the most ideal situation. Or imagine a real-life scenario where you have a military organization that's actually taking their equipment into the field. Imagine a bunch of soldiers running around not with equipment, but with servers on their backs because they need to run some data processing. That's not ideal. That's not practical. Even if you were going into a medical institution or a hospital, you would not find people rolling around with MRI machines and having a database server attached to it. A lot of medical equipment actually has SQL servers running on it. They're just embedded into the device itself. And previously, the SQL Server size was a little bigger. We've made it a little smaller so that it can fit on smaller form factors and smaller devices. And why are we doing this? Is because the range of devices and the power that each of these devices have are also becoming smaller. So in the cloud, I talked about Azure SQL Database Edge. The same SQL Server engine runs in our data centers today. How many of you use SQL Server for production? Like SQL Server 2017 for production? OK, that's a good number. So that SQL Server now, if you had to take it out of your data center and run it somewhere and into smaller devices like edge servers or even interactive devices like point-of-sale machines or even things like this kind of a Pi, that would be a little tough to do with the size of SQL Server today. So what we have actually done is we have actually taken the same engine and we have actually created a container. And what the container can do today, it can talk to the cloud and it can talk to your data center, but it maintains the same programming surface area, has the same features that your SQL Server has today. So if you have an application that is talking to a SQL Server database, you could literally back up and restore into Azure SQL Database Edge. And that would give you the flexibility of running it on a smaller device. Obviously, there'd be less CPU, there'd be less memory, there'd be less storage, but you'd be able to run the same code irrespective of whether you're at the edge or the data center or the cloud. So you're providing a fully consistent edge-to-cloud experience. Now, what is in this container? So in the container, we have a few things. The first thing is obviously the database engine. It can run your queries. It can do analytics. It can do machine learning. And apart from that, a key requirement of IoT scenarios is data coming in as streams. So you have sensor data flowing in from a factory floor, or you have sensor data like the video that I was showing earlier before the session. That's one of our customers that actually takes data from various ocean research, and they put it into their systems while they're at sea or the ocean. And they need to process that data while they're on the ship. And all of that data cannot be sent back up into the cloud or a central server because there's no internet connectivity sometimes when they're far out in the ocean or the sea. And in those scenarios, they need to process the data and prepare it so that when they're back docking at the port, they're able to transfer that data really quickly. So they were able to take their processing time down from 2 weeks to just 8 minutes because they were able to process all of that data irrespective of the amount of time they were out doing their exploration. They were able to process all of that on a single database that they used to do once the ship docked. And they just, with minimal code change, they back up and restore their entire environment on the ships that go out. So now they're able to process, and the time to insights is much faster. Their clients are able to get the information that they're requesting also much faster. So the ability to do analytics increases. But what if you were a factory floor and you're sending sensor data? Or for example, on social media, you get these news feeds in Facebook or your Twitter stream. Those are basically streaming data sets that are coming in And if you have to put that into a database, that can sometimes get challenging. So one of the things that we're actually doing with Azure SQL Database Edge is we're actually providing Azure Stream Analytics embedded into the engine. How many of you have worked with Azure Stream Analytics? Quick show of hands. OK, a few. So Azure Stream Analytics is an Azure service, and it provides you streaming capabilities. It's a PaaS service, and it provides you streaming capabilities, and you have to define a source and a destination. In this case, the source could be a machine sensor running on a factory floor, and the target in this case is the Azure SQL Database Edge table. So we have the Azure Stream Analytics running in the same container as the Database Edge. So any streaming data that is coming in can not just be processed, but even things like anomaly detection can be done right then and there on the stream. If you have streaming data coming into SQL Server today, you have to store the data and process it, or you have to write a stored procedure to do some analysis on top of it as an input data set. But right now, the incoming stream can be processed really fast, which gives you a very versatile ability for your applications to really process streams as normal unstructured objects so that you don't have to convert them into tabular streams. The other thing that we're doing is we're providing machine learning right into the container, so any kind of decision making can be done on the container itself. Once that is done, you can take that data set that's stored at the edge and you can move it up into your data center or into the cloud. Or you could even move it into Azure for training purposes. So if you have thousands of these sensors that are spread across different factory floors, you can aggregate all of this data into a single location and can do machine learning on top of it to create models. This helps you set up feedback loops. If you saw Rohan in the keynote yesterday, when we were doing the session on the Zeiss scenario, the Zeiss scenario is exactly this. You have a factory floor that is actually using sensor data, which is brought up into the cloud, and you can then train all of that data and create a model, and then you can push the model into each of these edge devices. And the last thing is, if you have these devices, you have to manage them. Logging into this thing, there's no remote desktop or an easy SSH that I can do to log into these things. How many of you are production DBAs here? Let's do a quick shout out on the number of instances that you manage. Like how many have managed over 10 production instances? 50, 100, 500. Wow, that's pretty cool. 1,000. 8,000. OK, the gentleman there wins it. 8,000. Wow. So in these scenarios, this is a $100 device, and it comes with all of the setup, all of the wiring. Generally, these are deployed in the tens of thousands. Sure. So if you're deploying tens and thousands of these, and they're not even in a data center, managing them is going to be extremely challenging. Just think of a simple task. Go find the IP address of all of these. There's no central server. There's no central monitoring environment that can help you drag all of these together. This is truly production IT nightmare. How do you manage so many devices that are running in different places, which are not even connected to your production network? They might be sitting in like totally air-gapped networks. So that's where Azure IoT comes in. Azure IoT gives you the ability to actually register all of these edge devices into Azure IoT, and that hub basically becomes your central management location. And each of these Azure SQL Database Edge containers are registered as modules into IoT Hub. And each of the modules can be pushed into each of these machines that you see here as edge containers. And for that, you have to register this with Azure IoT Hub. Azure IoT Hub can then connect to Azure IoT Edge installed on these machines. And essentially, you've actually created a central monitoring hub for yourself. And from there, you can start, stop, change settings, actually create a central policy which applies settings across You can create it by region. You can create it by role. You can do a lot of automation. And essentially, what you're doing is you're doing this on the Azure IoT Hub. The Azure IoT Hub creates a mirror profile of the configuration on this device and updates it whenever you change it on the IoT Hub. So that makes it easier to monitor. If you have your own solution, you could do that yourself as well. If you have a central IoT monitoring solution, you can register your devices and you can manage it from there. But attaching a number of operators or number of administrators to these devices could be immensely challenging. So what are the features that we're offering? We just announced a public preview for Azure SQL Database Edge. Obviously, if it's running on Raspberry Pi, we support ARM64. We run on containers. This is a container-based product. I talked about the capability for streaming. We provide that through Azure Stream Analytics. We also have built-in machine learning capabilities. We provide that through the Onyx runtime. So the Onyx runtime actually runs inside the container. So you can create your models, whether you're doing that in Azure ML or you're doing that with SQL Server 2019 big data clusters. Once you create your model, you can convert it to an Onyx format, and you can deploy it into the Azure SQL Database Edge instance. And as I said, you're already integrated with Azure IoT Hub, which gives you a great experience to manage the devices. So let's see how the deployment actually works. So you have an edge device. I have a Raspberry Pi, check. After that, you basically have to install the IoT Edge runtime on the device. Once that is installed, you can register the device with Azure. And then IoT Hub actually knows that there is a remote edge device that is actually there. And once the edge device is there, you will go to the Azure Marketplace, select the Azure SQL Database Edge module, which is essentially a container, and you will deploy that into this particular device. Once this is configured and deployed, you'll be able to connect to it. You'll be able to run queries against it. You'll be able to do everything that you can do with a SQL Server database engine. And then if you have sensors, in the examples that I'll show today, I'm actually simulating sensors. It's a little difficult to walk in with a factory floor for demos. But what we're going to do is we're going to simulate a sensor scenario where you're actually pushing data into the Raspberry Pi that I have and an x64 server, and we're going to simulate some analytics on top of it. So let's go look at how this actually works. Let me switch over to my desktop. So what I have over here is essentially Azure Data Studio. How many of you worked with Azure Data Studio? OK, so Azure Data Studio is a multi-platform tool. It can run on Linux, Mac, and obviously Windows. One of the cool things I really like about doing demos is if I forget stuff, it's actually written there so that I know what I'm doing, and all the output and all the commands are all in a single place. So the first thing is I have a notebook which will deploy. So I'm not going to do the command line deployment, but essentially there's a bunch of prerequisites. Like I said, you obviously need the Azure CLI. You install the Azure CLI on the machine. You log in, create your subscription, and then you can set your subscription ID. You can add the Azure CLI IoT extension. And in this case, I was basically creating a hub with the name Tiger IoT in the location Central US. In Azure, once the IoT hub was created, I registered the device. And all of these commands, once I do all of that, then I install Docker, configure Docker, and then I actually connect from Azure IoT Hub into this instance. So let me go log into that machine. So if you notice here, I'm actually going to open a command line terminal inside Azure Data Studio. And I'm going to try and log into my machine, which is a Linux VM. And typing out passwords during a demo is always fun. Oh, I got that. OK, so let's go look at what I have running on my machine. So as you can see over here, I have an image, and I'm running Azure SQL Database Edge on top of it, and I'm also running the simulator for the sensor data. So once I am running that, I can actually go look at what the data is actually doing. But before that, let me show you how the deployment would have worked if I was not doing it in command line. So I go to Azure SQL Database Edge. This is the Azure Marketplace. If you log into the Azure portal, go to Marketplace, search for Azure SQL Database Edge Preview. You will see that there's a preview module here. And once you click on the preview module, you will see that there are three options. There's Developer, Premium, and Standard. In public preview, the Azure SQL Database Edge module is free to use. You would have to pay for Azure IoT Hub and all the other Azure IoT charges, but the SQL module is free of charge in public preview. So for now, I'm going to click on Developer and basically set up the demo. So I'm going to pick the Azure IoT Hub that I'd created, and I'm going to say deploy to one device. And now, obviously, there are so many devices, I have no idea where to deploy it. I'm going to go find the device. So it says there are two devices. There is Edge 2 and Edge 1. I already have something covered on Edge 2, so I'm going to just install it. Sorry, I have something on Edge 1. I'm going to deploy it on Edge 2. I'm going to select Edge 2, and then I'm going to go click Create. Once I click on Create, I will see that there is a Azure SQL Database Edge module that is showing up in the page, in the configuration page. Now I can go ahead and click on Configure. What this allows me to do is it allows me to set the parameters. In this case, obviously, I want to set a password. So I'm going to go set a password there. And this is the container create options. If you have run SQL Server on containers in the past, you will notice that these are similar settings. It's just that it's provided in a configuration file. We're defining a persistent volume. We're choosing the port number. And so I'm going to change the port number to 1445. And then I am actually saying agent. So as I said, this is the same SQL Server engine. You actually have SQL Server agent also in there. So it's not like you're getting something which is not the same. So in this case, I'm not going to configure the ASA job just for demo purposes. I'm just going to save that. Once I have that saved, I'm not going to configure anything in the routes. And I'm just going to go click on Submit. So once I click on Submit, what this is actually going to do is it's going to start pushing down the module. So in this case, you see that it says that the device configuration is not there. So in SQL DB Edge 1, I'm going to actually go into that and show you what's already there. I'm not going to wait for the module to deploy itself. But in SQL DB Edge 1, I have already deployed that. And I have the device ID, so I can go click on Set Modules. Now, in the module, you see the data generator. The containers that I showed you when I logged into my machine, those are set from here. I am not installing anything directly on the machine. I'm actually logging into the machine from this console here just to show you what's there. But all the configuration that I'm doing, everything that I'm pushing into the device is being done through Azure IoT, so that you have a single place to monitor and manage all of these devices. So I have two modules. This is a custom module, which basically acts as the sensor, which generates data. And this is the actual Database Edge container. So let's go look at what the Database Edge container looks like. I have the username. I have the password in there. Obviously, having it in clear text is not great. That's something we're working on. And there's a restart policy defined. So these are unmanned devices. You don't have DBAs attached to these devices. So how do you actually manage them? So those are also being managed as long as they have network connectivity. They're being managed through Azure IoT. And additional policies are set. So for example, the device is configured to always restart the container if it fails. So if it fails for some reason, it's always going to restart it. The desired state is always set to running. So if it goes to stop, something will trigger, and the IoT Edge module will restart it. So these are the kind of things, the management capabilities that you can get with Azure SQL Database Edge. The other thing that you can do in addition to that is obviously you can add additional custom modules that you write, and you can push it into the edge. So let's go back and see what else do we have. So that was what the deployment looks like. So let me go back to my deck and talk about what we're actually providing. So I talked about machine learning with SQL Database Edge. Has anyone here worked with R or Python in SQL Server? Yeah. So R and Python basically gives you machine learning capabilities with SQL Server. You're able to use T-SQL as a language or the predicts function in T-SQL and run machine learning models on top of data which is stored on the database. The advantage of doing something like that is you don't have to move the data out to a remote machine to do machine learning. That speeds up the time to insights. The same concept here. You can take any of these machine learning frameworks. You can create a model. Once you create the model, convert it to Onyx, and use any of the tools that you want to use to convert it. You can use something like MLflow to push that into the Azure SQL Database Edge. And then any data that's coming into Azure SQL Database Edge can be used to predict any sort of output that you desire. So whatever you were doing with R and Python, you can actually now do at the edge, but using Onyx as a runtime. I'm going to stop here and see if there are any questions. Questions? OK. So, yes, ma'am.
So if we use Python, do you mean we need to save the code to SQL?
So if you're using Python to generate the model, once the model is generated, you would have to use an Onyx converter to convert that model into Onyx, and then take that Onyx model and push that into SQL Database Edge. So the question was, do I need to save the Python code into SQL Database Edge? No, we don't have Python and R integration in SQL Database Edge, so we're using Onyx as a runtime to execute the model. So you will essentially train your model somewhere else, and you will push it to the edge. The practicalities of running R and Python on smaller devices like this can be a little challenging, especially with the sizes of the Python and R libraries that you might have to download. So which is why we're only talking about running the scoring, not the training. I'm not even sure if you would want to use Raspberry Pi for training because it's just too small a form factor, and the compute and storage might be a lot, depending on what kind of SD cards you attach to these devices, or even the sensors, but the compute capacity typically on these devices are pretty small. So, sorry? Yeah, so the T-SQL, the questions am I talking about T-SQL Predict? Yes, I'm talking about T-SQL Predict, but with T-SQL Predict now, previously you could only call R. Now we are actually integrating that with Onyx runtime as well in the container. So now you can actually use Predict and call a Onyx model that is stored in the database. So once you have all of this done, you actually can create a feedback loop. If you're not happy with the results, you can send the results back to the cloud or your central server, or SQL Server 2019 big data clusters, and you can actually retrain the model there and push it. So you can actually create a nice training cycle where you're training in the cloud or you're training in your data center, and you're scoring directly at the edge. So once the training needs are done, let's look at how you would actually build in a connected scenario. So in this scenario, if you look at, I've talked enough about the sensors, but when the sensors are pushing data, right now in the connected scenario, all of the sensor data has to land in the Edge hub, and the Edge hub will then push the data into the container. And whether you're using the container to run stream analytics to detect anomalies or to do any causality analysis, that's option A. Option B is you can store the data directly into SQL Server as well. So the choice is yours. Depending on how the data is coming in, you can write code to actually push data directly into SQL, or you can push data into Azure Stream Analytics, and Azure Stream Analytics container, the running inside the container, will process it and push it into the SQL database. You can use machine learning to push the model into the database, and then depending on what you do, you can do one of three things. You can do analytics at the edge, because you have your full power of T-SQL running there. You could actually use machine learning, or you could even do filtering. So for example, every time a power grid shuts down, so if you live in the Seattle area or in many other parts of the country over here, there are lots of smart meters, power meters, that are being set up in a lot of homes. And they actually transmit data back to a central facility. So it's quite impractical for a human to come out every time there's an error in the machine. So you might want to just send back the anomalies, like machine shut down, or machine detected a temperature level which is higher than normal. And if all of that data comes back, only the anomaly, you've drastically filtered the amount of data that's going over the network or over the air. So that amount of data set being moved back is drastically reduced. So this can also serve as a filtering mechanism. Yes, sir? Okay, so the question is, how does the Edge Hub and IoT Hub come into play? So essentially, when you're deploying the device, depending on how you're actually going to get the data, that is entirely dependent on whether you need an Edge Hub or you can directly insert into the database. So the database is essentially an instance of SQL, which you can directly connect to, and you can actually write queries against. But if you want to do stream-based processing, like streaming data, today you need to go through Edge Hub. So IoT Edge Hub integrates with Azure Stream Analytics, and you have to go through that. We're working on an experience which allows you to do something where you don't need to have Edge Hub in an offline scenario or have Edge Hub fully contained in the device itself. That's something that we're working on. We don't have that yet. So which is why, to the gentleman's question, we need Edge Hub for now if you're doing a stream-based processing. If you're inserting directly, like you're writing an insert query, you don't need the Edge Hub. So the cloud piece remains the same. So these are all the cloud services that you have. All of that, you could use something like a SQL agent job. I showed you that there's SQL agent there. You can actually use a SQL agent job to send data back directly to the cloud, or you can use something like Azure Data Factory, or you can use any other Azure automation capability like Azure Automation or Azure Functions to connect to that edge device and pull that data back in. So let's talk about a customer scenario. The video that you saw, that was a shipping company. They actually process all of the data on their ships, and they filter all of that data. Once they dock, they actually push all of that data into Azure. The data is then trained in Azure, and the models and the analytics insights are sent back into the device again. This actually helps them speed up their turnaround time. The other one was Carl Zeiss that you saw. They're in a different scenario. They're not connected. They're totally disconnected. They're in a factory. Each of these factories have various machines like polishers, grinders, and if you have an optical instrument from Zeiss, you would essentially, those are coming from one of these manufacturing lines. And what they have to do is they have to actually predict what is the quality of the lens being produced. So if you're wearing a Carl Zeiss lens, and if you're seeing blurry images, that's not going to be a great experience. So you want to make sure that these guys are actually producing lenses which are of high quality and have high optical ability. So in those scenarios, they actually have to take readings of every lens that is coming out and match it with the quality controls that they have. Right now, because you're not able to process data at the edge and they have no ability to store data, the data comes into a central server where it's processed. So which means that there could be a period of time between when the data flowed into the central server, when the analysis was done, that a bunch of lenses were produced. It's an automated manufacturing line. So that actually could lead to a lot of wastage, because let's say you found an impurity or you found a quality issue because of some parameter that you changed, all of those lenses or all of those optical equipments would actually have to be discarded. That actually leads to wastage. So if you were able to take that central processing which is happening in a SQL database, you could actually push it right into the machine using a container, and you could take the decision right there. So your ability not just to predict or react faster, you also have the ability to A/B test. For example, if they got a huge order and they need to change the parameters to produce things faster, they can test with one production line just by pushing the settings into that production line and checking quality, as opposed to them having to make a change for the central system which modifies everything. So your ability to react and predict faster actually leads to greater efficiency and also makes you take decisions faster. So let's look at how this would actually work in a database edge scenario. So I'm going to switch back to my desktop, and let's go look at the edge module. So I'm actually going to simulate a scenario. So what I'm doing is, with the RNO data generator, I'm actually going to predict the amount of impurities or the percentage of silica being produced, and the sensor, the container that I have, the RNO data generator, that is actually simulating sensor data at a fixed frequency. So I actually have a bunch of Python code that I'm running. So what I'm actually doing is I am creating a workspace, and I'm actually using Azure ML to create the model. So I've created an experiment. And right now what I'm doing is, and this is something that's pretty cool, is I'm actually using a data set from Kaggle, and I'm creating a training data set to train on top of it. So if you notice here that this is a CSV file, and I have no idea about what the format of the data set is. So especially when you're importing data from a CSV file, especially when you insert into SQL Server, one of the challenging things is getting the schema alignment done correctly, right? So I've actually, what I've done is I've done a read of the CSV using Python, and then I'm basically asking my Python to give me the schema. Do you see 2 lines? I just used 2 lines of code to give me the schema from the CSV file. I did not specify a schema input, and it just gave me the schema of the table in the CSV file. You can actually take this code and use it in SQL Server to do bulk imports. So now what I'm going to do is I'm going to actually go look at the histogram. So I have a bunch of columns here. So if I have, right now I've got 8 rows and I've got 23 columns. If I want to go look at the data set, so the data set that I was processing was close to 180 megs. So now I'm going to go create an experiment, and I'm going to do a bunch of things where I'm going to basically divide up the data. So right now I'm looking for skew in my data set. So again, I'm not going to delve a lot into the data analysis scenarios here, or the data engineering here. So what I'm going to focus on more is I'm going to show you once all of these things are done, I can actually use something like AutoML to run an experiment. So when I run the AutoML experiment, what I'm actually doing with this data set is I'm actually asking it to evaluate a bunch of models. So if you look here, I'm basically setting the iteration time to 1 hour, and I'm asking it to do 10 iterations. And for someone like me, that's probably, I would say, if you have categorizations of expert level, I probably fall below a noob when it comes to machine learning. So I'm just going to rely on code, which is in the demo, and I'm going to say, hey, AutoML, tell me what is the best model to predict the output. I know what the output should look like. Like when I use a blind spot monitor, I know that it should tell me there's a car behind me. Or when I'm pressing the brake, I know the car should stop. I have no idea how it actually happens, but I just know what the final result should look like. So in here, I know what the final result should look like. I know that it should tell me what the percentage of impurities in the production should look like, but I have no idea how to get it done. So I'm just going to rely on AutoML. But if you're a data scientist and if you have a data scientist skill set, you'd probably want to look through these results and figure out that you're getting the right model. So what this is doing is actually using my local machine to run the AutoML using Azure ML. It's doing the training. And each of this, what it would do is it would show you the duration, it would show you the metric, and it would show you what was the best score among all the 10 iterations that it did. And once it does all of that, you would get to see models which will be created. So in the interest of time, I'm going to go show you when I actually create the models. I have various different models that I created. So an Onyx model would be created. You can use open source tools to go visualize that model. Once the model is created, I will deploy the model to Azure SQL Database Edge. And what I'm doing right now is I'm actually inserting the model into a table inside a SQL database. So let me connect and show that to you. So I have SQL Server here, but no, that's not a SQL Server. That's an Azure SQL Database Edge. I have connected to it. And I'm going to open up a new query. And I'm going to do a select add version. And this is a 64-bit Azure SQL Database Edge. It's in public preview, which is why it's CDP. It's a developer edition. But if you look at the view, it looks and feels like a SQL database. And it is a SQL database. And it is a SQL Server instance. It is just that it is optimized to run in a smaller form factor. So if I look at all the models that I have, so let me switch the database context. So I have all the different models loaded. And essentially what I'm doing is I'm storing the model as a binary image. And what I am going to do in my notebook now is to speed up the demo. I'm just going to connect to it, and I am going to run a query to get the best prediction from the data set that I have, which is being generated in the module itself. So if I want to look at what's running inside my model, so let me go do that. So I'm going to SSH into my machine. So this is what you're actually seeing right now is actually a error log of SQL Server. But in that error log, you also see an output of Azure Stream Analytics, the engine that's running inside the same container. And what it is actually doing, it's actually giving you an output of all the data generator. Remember the data generator that I showed you? That's actually pushing data into this container. And Azure Stream Analytics is processing all of that data set and giving me that output. So now, if I go look at the table that's there, I'm going to go to top 10%, and I'm going to just select from that measurements. Sorry, top 10. So this is the data set that I have. And I can actually, if I wanted to, I could actually go visualize this in Sandance in in Azure Data Studio, I can actually look at things like what's the correlation between the data sets. For example, if I want to look at the correlation between my iron and silica, I could do that. I could change it into a 3D view, and I could go look at that data as well. And then I could say, okay, show me what the value looks like. So I could visualize the data in different views. And I'm doing all of that in Azure Data Studio. Yes, ma'am?
Question. Does model use the data from CSV file, or does model use the data in SQL Server? Because CSV file, if it's a small file, it's okay, performance okay. But if it's a huge file, when the model reads the file, it takes some time.
So that was used for training. You could use the data set from inside a SQL database. Right now, for scoring the data, if you see here, I'm actually going to score the data from the table where I just pulled the data from. And I'm actually using the predict function to score the data. So if you see here, I'm actually running the scoring from within a SQL Database Edge table. And that's nothing but a SQL table.
But source data is in a CSV file, or source data?
So source data, that's the source data. This is where the source is. The source is sitting inside a SQL table. Now the model has been trained and the model has been deployed in the database. The Azure Iron Ore Data Generator container is acting as the factory sensor. That is the simulated sensor, which is sending data into Azure SQL Database Edge container. The Azure SQL Database Edge container has stream analytics, which is processing the stream and storing the process stream inside a SQL table, which is called Iron Ore Measurements 1. And I'm going to use a Onyx model that I created outside of the container on my machine using Azure ML. And I'm going to deploy that model, which I've already done, which I showed in the models table. And I'm going to use that model, which is deployed. So if you look here, I'm actually selecting that model. So I'm actually selecting model number 5 from my table. And I'm going to use that model to predict data that is stored inside the SQL database. So once I do that, I get the output. And then, because this is Python, I can use Python graphing libraries to actually create a nice little graph. So that gives me a visual view of how much is the iron feed, how much is the silica feed, and how much is the silica percent. And if you notice that the silica percent, which is the blue line, has certain spikes at a period of time. And if you see the correlation at that time, the iron feed is also higher. So you can actually get a visual view. And all of this I'm doing sitting inside SQL Server tools and a SQL database. So essentially, anything that you could do inside Azure, you could take all of that into your data center. And if someone says, no, I need something smaller sitting right beside the machine, you could do that as well. Now, just for kicks, I was like, you know what? Let's go look at how this actually really works. And does it really feel like a SQL database? So how many of you were in Bob Ward's session or any session where scalar UDF inlining was talked about? OK, so scalar UDF inlining is a feature in SQL Server 2019 where if you have UDF functions in your query, it can perform really slowly. We actually use scalar UDF inlining to make the processing go faster. So what I've done, I'm connecting to my Azure SQL Database Edge container. I'm actually going to connect to the sample database, which I restored in my container. And right now, I'm going to run a query. And what that query actually does is actually it has a user-defined function, which is not good coding practices, but it actually helps in a lot of scenarios. And it gives back a bunch of results. And if I look at the function output, you will see that each of these functions got executed 121,000 times. And that is exactly equal to the number of rows that my query had returned. So now what I'm going to do is I'm going to set the compat level to 150. And this is what you can do in SQL Server 2019. I'm going to attempt to do that in an Azure SQL Database Edge container. So I'm going to run this in an Edge container. And once the query executes, it's running in the same amount of time, and I can then go see how many times the function got inline. Every time the function gets inline, I have a extended event session running. So again, something that you would do on a SQL server, like running an extended event session, I'm actually running that on a database edge container. And just to make sure that I'm not making stuff up, select add version, shows you that I'm actually running it on an Azure SQL Database Edge container, and it's a CTP and it's Developer Edition. So now let's do this. Let's actually use Management Studio and see what happens. So in Management Studio, I'm connected to a machine, and you can see the agent job in there. It has the same database that's created in my Edge container. But over here, when I run add version, you see that I'm actually running on Ubuntu, and now it does not say just x64. It actually says ARM64. So I'm actually running SQL Database Edge on an ARM64 machine. And does it look and feel the same? Let's find out. Let's run the top 10 queries again over here. So if I look at the tables and I do a select top 10 star from RNOR measurements, and in this case, it's a smaller machine, so I just have 3 gigs of RAM, and I have only 6 virtual CPUs, which means it's a pretty small device. Okay, so I need to change this to the right database. And once I do that, again, so the key message that I'm trying to drive over here is that irrespective of where you want to run your SQL database and your SQL Server instance, you don't have to write different code to do it. It's the Edge, which it's a new product. It's Azure SQL Database Edge. Integrates with Azure IoT, has streaming capabilities, which are specific requirements for IoT or Edge scenarios. You have SQL Server running in a data center, and you have SQL Server running in the cloud, which is Azure SQL Database. And Managed Instance provides you the full instance capabilities. So essentially, you have the same scenarios happening. Now let's go actually log into one of these devices and see what actually happens there. So if you see here, it's actually saying I'm logging into a Rock Pro machine. And now what I'm going to do is I'm going to show you the containers that are running there. And again, on a Rock Pro 64, first it says Ubuntu Bionic Ambient Linux. And I am actually running a instance which is on ARM64. So I'm running an ARM64 v8. And if I want to look at the logs, so again, I have the Azure Stream Analytics stuff that's actually running on that. And as you can see, that this just looks like any other SQL database. So this is actually the device that I'm connecting to. So once you, so if you see this over here, I'm connecting to these two, the same devices. And essentially, irrespective of how you connect, whether you use Management Studio or you use Azure Data Studio, all the features are the same. I showed you a sample database that I actually restored on the same container running on ARM64 and x64 Database Edge, and it's running the same functions. It's just that the form factors are different, the use case scenarios are different, and pretty much your experience is the same. We're trying to drive the same consistent experience across the board. So let me close this out by talking about what we're going to deliver in the coming months. So right now it's in preview. So when we actually go into general availability, we will have time series capability, or we're looking to build time series capability into the database edge. And the idea of that is you would be able to use the SQL Server database to actually store time series, time windowing capability on the database edge container. You already see that there's Onyx. We will provide additional management capabilities which will allow you to manage these deployments at scale. Someone said 30,000. What if it was 100,000? If it was 100,000, that might be a little challenging to run updates. Simple things that you do in production, like push out updates. If you had to do it to 100,000 devices and you had to do it within a very short period of time, that's going to be challenging. So we're going to provide additional management capabilities which lets you manage these instances at scale. And at the end of the day, this is the same SQL Server engine. Perf and scale are obviously limited to the amount of CPU and memory that you have. We will always give you the same security benefits as much as possible. It's like, for example, enclaves does not work on this because these small devices don't have enclave support. But for example, if you wanted to use something like column level encryption, you could do that. If you wanted to use things like transparent database encryption, especially when you have sensitive data. If you have a medical instrument where your patient data is being stored, that is high impact or high business impact data and PII data, things like transparent database encryption will give you the ability to store sensitive data in a secure manner at the edge. A lot of times, these instruments don't store sensitive data because you have no means of storing data securely outside of a data center. So these devices also, with SQL's built-in security features, gives you the ability to do so. And at the end of the day, whether you run on edge, whether you run in data center, whether you run on the cloud, Microsoft strives to provide a consistent experience across all three targets so that you have to only worry about where you back up and restore your database and not having to rewrite your application. Once again, this is in preview. You can go and look at the Azure SQL Database Edge homepage. There's a sign-up form. We're only taking sign-ups through registration. So once you give us your Azure subscription ID, we can whitelist it. And once you whitelist it, the view that I showed you when you went to Azure portal and looked at the Azure SQL Database Edge module in the marketplace, you could deploy it in a Raspberry Pi. You could even do it in a VM for testing purposes. Or if you have a true production scenario like our customers that they're doing on their ship or in their manufacturing equipments or in other MES systems, you could do that as well. And once you do that, you'd be able to actually run a small database container with the same SQL engine in a different device sitting outside the data center or even in a remote location. If you have any feedback, there's a feedback form there, or please feel free to reach out to me. Please fill out evaluations. We actually appreciate any feedback that helps us improve. So thank you very much for coming. Those are my contact details. Feel free to reach out to me. And once again, thank you very much for coming to the session. Have a good rest of your day and a good PaaS Summit.